Hello everybody, welcome to the third part of the Openthread 101 video series, and in this video I will show you how to set up your development environment. Nordic Semiconductors now uses Visual Studio Code for their development and that supports it really well, so we would just open Visual Studio Code. Hopefully you have it already installed. Then they provide some extensions and we would use them. So let's search for their extensions. So we would just search NRF Connect pack, and this extension pack includes all the extensions that NRF supports or they suggest. So it includes the Connect for US code, the terminal, something called kconfig, device tree, and then some GNU linker map file, CMake, and C++ extension. So let's just install these extensions, and yep, so these are now installed. And what we can do now is go to the extension, NRF Connect extension, and first step we need to do is to install our toolchain. So let's just select that and it will download and install our toolchain. Toolchains are basically compilers and debuggers and things like that. Let's wait for it to finish. Okay, so now the toolchain has been installed. Next step is to install the SDK. So we just install also the latest version of the SDK and we would press enter on the default location. So they will start installing it. It will take some time because it will clone a lot of the Git repositories. So we will be back once the installation is done. Okay, so now the SDK has been installed. There is one more step in the toolchains that we need to do. So if you click here and select validate toolchain, it will tell you that there is something missing. That is because so the toolchain also includes tools for flashing your hardware, and some of the dependencies here are missing. These are from third parties or dependent on third parties, I guess. I don't know why those are not automatically included. Maybe because some licensing issues or whatever. So there's something missing called Segger JLink software and documentation pack, and then there is the NRF command line tools. So we will just copy the name NRF command line tools, open our browser, search for it, and go to the download section. And here you will see that there is an important notice here as well, that the NRF command line tool is in the process of being archived, and a newer tool called NRF util would be replacing it. But for now we will just continue with it. So just download the deb file. As you can see, it's naming it because I already have one file downloaded, but just for your system, download the file that you need. So now we can install it. So we go to downloads and then we install it. NRF command lines tool.deb. So we will just install the one which I had downloaded before, and it will, during the installation, it will tell us that the JLink part is missing. So, but it the good part is that it already comes with it. So we can just copy this command that it gives us and we can run it, and just make sure it's on the same line and enter. Okay, so now the JLink part is also done. This one we would just leave out for now. But if there are some errors, then we will know and we can install this one as well. But I highly recommend to install this. Now that we have those tools installed, we can run the validation check again, and now it says no issues were detected. Now let's create an application. So we would just start with the sample application, and it's always good to test your development setup by using some samples that you know are working, and that way then you don't have to worry too much about if something is breaking. Here we will just give it the path to the home directory, and we would open the application, and now you can see that here you have the source codes, the C source file, the CMake file, and the configuration file for Zephyr, some README file, and some YAML file for running some tests and things like that. I don't know what this is for in too much details, but I think it's related to running some tests. There's some tool called Twister. It's, I guess, from there. If there is time, maybe we would have a look at this. Here you can see that the IntelliSense is not working yet. It is because we don't have the build system configured. So build configuration, and so what we can do is do the build configuration. So to do the build configuration, I will redo it again. Add build configuration, and then we just select our board. In this case, it's NRF52840 development kit, and here they have two variants. So this is just, these names are coming from Zephyr. So Zephyr, each board has a name, and this is the name for our board is NRF52840DK/NRF52840. So we select that and then do a build configuration, and it will basically create all the build configuration and would compile our application as well. So let's just wait for it to finish the compilation. Okay, so now the build has been completed, and you can see that this error is gone now, and all the IntelliSense stuff has started working. Here you will see also a view of the files. This is, I think, for people who are used to the Segger Embedded Studio. So this is how they can see the files. So here, the main file, main.c file, is here in this case as well. Now let's flash this device. If you can see, we have no device connected. So if you try to flash, it would say no device connected. But here is the normal flash, and then here you can do erase and flash the board. For building, here is a normal build, and then here this option is for pristine build, which means it will remove some of the build files and then rebuild them again. Here now I will turn on my development board, and you would see this in a minute here. So here now we have our development board. So let's flash it. So the flashing is done, but because we are not connected with the serial terminal of the device, we don't see anything. but the extensions from Nordic, they already provide you a way to connect with serial terminals. So on the device you would see there the port where you have it connected. What you can do is select this connect to serial port option. Select the options that it gives you. Usually the default ones are fine. And now you see that it is connected to the board, and if the UART was printing anything, it would show it here. In our example, if you look at our example, what we have is we just print it once. When the device starts, then we have the hello world printed. So in order to see this, we can reset the device, and here you can actually reset the device right from here, so no need to power it on and off. And here now the device has been resetted, and you can see that you see the print. Also you are seeing some logs from the booting NRF Connect SDK using Zephyr OS. So NRF Connect SDK is basically a fork of the Zephyr OS. NRF is just adding some of their own modifications and maybe some proprietary stuff to it, and that's how they use it. Let's test this one as well. So we would change the text that it prints to hello world and then Openthread 101. Let's say this is what we would do. Let's try it. So in this case, I guess if I flash it now, I'm not sure if it would be flashed. These changes would be flashed, but let's try it. Let's see. So it's okay. So it did, I guess, the build. It did build it new, and yes, so it did build because it noticed that this file was changed. So even though I just clicked flash, it built the file which was changed. So that's something, I guess, coming from CMake, or those tools are intelligent enough to detect this. But sometimes sometimes it might not work, but those are really rare. Okay, so now that we have this example running on our actual development board, what we can try to run it as a simulated environment or emulation. So there is something called Renode, which provides a really nice simulation. This video is not sponsored or anything, but this is a tool I like to use. It supports a lot of different architectures as well, and it's really helpful to automate your tests or just test your firmware. In this case, you just download the dep file because you are on Ubuntu, and we will install it. So here we would have to provide the path. So it says we already have it installed. I had it installed before recording this video. So it's already installed, but this is how you can install it. And then to run it, what you do is type renode, and it will start as a window. It will start a new window called monitor, and yeah, this is how you interact with renode, and these are the commands available to you. The most important ones for us are include command and start command. So include command basically loads a script. A script in Renode can define your hardware. So in our case, we would run the script for NRF52840, and just to show you what that script is, it's Renode 52840 script. Maybe hopefully it's intelligent enough to. Okay, so this is the GitHub. These are the script directories. Here you have these scripts, complex scripts, multi-node scripts, and for us the important one is single node script. And then we are interested in NRF52840, this script. This is the script that we would be running, and in this script you can see that it's not very long, and what it does is basically creates a platform from already defined platform, and then it specifies a binary file that it wants to run. In this case, if you just run the script as it is, it will run this this binary file which is hosted in the cloud. I think this question mark equal is I don't know the syntax, but I guess this is to, if bin is defined, then it will not load this, but I'm not sure about this. But if you run this script as it is, it will run this binary file, this firmware file, which is hosted by Micro. Micro is the company behind Renault, and show analyzer will open the UART 0 of the device in a separate terminal window, and you would be able to see whatever is the device is printing on UART 0. So let's run this script first as it is, and then we would run this script with our own binary file that we just used. So what we can do is type start, or maybe we can type include, and then hit the rate, and then scripts. So I just type tab and it will autocomplete, and if you do a tab again now, it will tell you the possible combinations here. The possible combination, just as you saw in the directory in the GitHub, these are the directories. So you would go to single node and NRF52840. So this is our script that we were looking at. So we will just include that script, and you see that that script already started the UART 0. This window would show you some errors if there is anything, but this is usually the logs, you can think of it. I have to increase the sizes of these windows so that you can see them, but you just have it as it is now. To start the simulation, you can just type start, and now you see something on the UART coming up, and that's basically the UART of our simulated hardware. If you type help, it will show you all the possible commands. It's some CLI from Zephyr, so Zephyr version 2499. Yeah, this example is from 2499, but yeah, this is basically the UART of the device. So now if you want to quit, we would type quit in the simulated in the monitor window, and then this thing also stops. Now we type clear again. We start. In order to run our binary, first we have to go to our project folder. So from the terminal, when you run Renault, it will automatically include the directory where you're running from into something. You can think of it as like a path. So what we do is we go to build directory where our binary is included, and then in the build directory there is another hello world directory here, and then here you have Zephyr directory, and our binary file is then this Zephyr.hex file. It's somewhere here as well. So this is the file that we would want to pass to Renault. So let's run Renault here in this directory, and we would increase the size a bit. Now what we need to do in order to use that script is we would specify that .bin now is equal to zephyr.hex. I don't think the autocomplete would work here, especially in this command, but if you do just zephyr.hex, then it would work. But somehow when we are setting a variable, then the autocomplete does not work for the current working directory. So we will just do $pin at zephyr.x. If you want to specify something else, then you can also do absolute path, or you can also do like the current working directory and then zephyr.hex. But we would just do zephyr.hex, and this is set. Then we would include our, or you can include, or you can also just type start at scripts, single node script, and then nrf52840, and it will start the script. And something went wrong because it was not able to find the file. It says there was an error executing command because it was not able to load the binary file. It could not load ELF. Okay, so I think we probably need to load not the hex file but the ELF file. Let's see, there is an ELF file probably. Okay, so maybe this is the file that we would need to load, I guess. Let's try it again. zephyr.elf start at script single node nrf52840, and yes, now it works. So we would have to load the ELF file, which is yeah, the executable. The hex file is I think some kind of packaged, but I don't know too many differences on top of my head, so we would have to look if I want to explain it to you. But now you can see that the hello world is the example is running, and you can run your firmware in a simulated environment. And now we can quit from here, and it will quit, and then we exit from here as well. This is the source code. If you go to the scripts and multi-nodes, you have nrf52840 BLE Zephyr, and you have another one as well. So here you can see the script is a bit longer. This is used for BLE testing. One of the benefit of Renode is that you can have simulations where you have multiple devices, and it also allows you to simulate the media, the transmission media, the communication media, or like the air, you can think of it, to test wireless communication between two devices. So here in this case, it's something that simulates a BLE medium, and in future video we will try to simulate something Openthread, so multiple devices with Openthread. I hope this video was not too chaotic, and it was useful. Thank you very much for watching, and see you in the next one.